tubule, but it happens throughout the tubules and even a little bit in the collecting ducts, which is after the nephron. Any questions on reabsorption? Tubular secretion is for the things we're sending the other way. It's almost always by active transport because those substances that are small enough to filter would already be in the filtrate at a concentration equal to plasma. So you need to put some effort behind it to get more of them in there. What's secreted is generally things we don't want in the plasma. Hydrogen ions are a big one. Potassium ions, it's not that they're unneeded, it's that they're more important inside the cells so we can spare what's outside the cells. And we need to do an exchange to reabsorb the sodium. You remember that sodium-potassium pump that shoves the sodium one way, the potassium the other way? That's also the major way that we reabsorb the sodium. So the potassium is just kind of lost as a byproduct. The hydrogen is lost to adjust body pH. And that's the reason urine is usually acidic. Drugs that weren't secreted in bile can be secreted in the urine. Penicillin is one example. And that's the only one I would ask you to know. Anything else you'd have to look up, okay, is this excreted by the liver or the kidneys? Now, what's not listed here is the metabolic wastes. We'll talk about those coming up and why they're a little different. So here's secretion and reabsorption together. We're secreting the pink substance, reabsorbing the blue one. And before the point that it's happening, we've got mostly the blue ones in the filtrate. And then after that, we are changing concentrations, and they're ending up more equal. The major metabolic wastes found in urine are urea, uric acid, and creatinine. Urea comes from deamination. So when we take the amino acids, we cut the amine off to burn the rest for fuel. The amines are built into a molecule called urea. This is the major waste that's in the urine, and it's the reason urine is yellow. Urea is yellow. Uric acid comes from breakdown of nucleotides. Creatinine comes from creatine in the muscle. If you remember creatine phosphate, that can replenish the ATP quickly. It can't just be reused forever. It's gradually replaced and it's broken down into creatinine. What's weird is that we don't secrete these wastes very much. Urea and uric acid, we actually reabsorb some, but they still end up more concentrated in the urine because you've got 180 liters worth of urea and uric acid going into the tubules, and then you reabsorb 99% of the volume, and you're leaving them behind. The creatinine isn't actually reabsorbed or secreted. It's just filtered, and it's lost at a constant rate. Questions on wastes? So here's a comparison of the concentration of substances in plasma and filtrate versus urine. You'll notice that the plasma and filtrate concentrations are all identical. And that's because it's just filtered by size, not by what we want and don't want. Then if something is reabsorbed in at least equal amounts to the water, then its concentration will be lower in the urine. We see that with the sodium. It's not a lot lower, but it's a little bit lower. Down here, the glucose, there should be none in the urine. If something is more concentrated in the urine, that means it's at least not reabsorbed as much as the water is, and it may even be secreted. we've got the potassium. It's secreted, it ends up a lot more concentrated in urine than in plasma. Same thing with several other ions. The bicarbonate, that's a reabsorbed one, so it's a little lower. Down here, our urea, much, much more concentrated in the urine, but that's almost primarily due to the very little being reabsorbed rather than from secretion. Same thing with uric acid and creatinine. Before I run this video, let's pause the tape. After I run it, we're going to